Okay, so for the solution to exercise 2, we can pretty much start off with our template again, just like before. I've even initialized my array to all 0 values. I've also, however, introduced an extra variable, in this case called sum, and I've initialized it to 0. The purpose of this variable is simply to store the sum total of array values. So effectively it will be, of course, the user's input values. So I'm using this just to basically store the sum total calculation of these values. Okay, I'm going to use that later at the end of the program. Okay, so the first order of business in the program is we have to capture user input. So I'm directing the user, I'm being user friendly here. I'm telling the user please enter, and then here I didn't specify 10 in my string. Instead I inserted %d. Why? Because I want to refer to size. Because I have my constant size here that I'm using with my array, I'm going to stick to that constant, because if I change it to 100, I don't need to go and alter my code. The array will contain 100 values. It will ask the user to enter 100 values, and when you look at this loop where we actually capture the user values, size will then become 100, which means the loop will run 100 times. Alright, so we have it at 10, so our loop will in fact run 10 times, and it will ask please enter 10 values. Alright, so then the loop runs 10 times. Every time it asks enter value. Once again, I didn't manually list out 10 different strings. Instead, I just inserted %d into my string, my conversion specifier. And what value do I want to insert there? I plus 1, because it shouldn't start with 0, it must start with 1, but we know I starts with 0, so we have to shift it up by 1, we have to add 1. And then we capture the value with a scanf. It's an integer value. I store it into my current array element, which means the first iteration of the loop will store into the first array element, the second one, the second, third, etc. And what I also do immediately after that is I take this value, I read it, this is a read statement from the array to the right here, and I add it to whatever is in sum. Plus equal to is the same as sum equal to sum plus, and then some value, which is this value. Alright, so I relatively add it. It's a relative operator here, not absolute, it's relative. I add it to sum. You can see for the very first time this happens, sum has to be 0, otherwise there will be a bias and the average will be miscalculated. That's why it's important to initialize sum to 0 up here. Okay, so it will constantly add the value of array to whatever is already in sum. So by the end of this loop, when we have 10 values, the sum total of those 10 values will then be stored into my sum variable. Okay, I will need this, of course, to calculate the average at the end of my program. Okay, so let's first continue. The next step that we want to do is we want to print out to the screen. If I run my program, you can see please enter 10 values, enter value 1, and that's from this loop here. So I'm just going to quickly type in 10 values. Alright, the moment I hit enter, we see the array values, and then listed out here. That's what this loop is for. It prints out array values once before the loop, and then in the loop we print out each value separated by a space or 2. Alright, so you can see here we're simply reading from the array and displaying or printing to the screen. And then down here, this is where we finally get to our average. So we actually calculate the average inside a printf. Okay, that saves some time, it saves some memory space, because otherwise I would have had to create yet another variable called average, or I would have had to use sum and override the sum total of the average. But I opted instead, since this is the last thing of our program and we will not need this average value again, I simply opted to calculate it in the printf statement. So you can see the printf prints the average value is %.2f. We know that will round the value to 2 decimal places after the comma, as you can see there. We also said it's a floating point value. Why? Because there's a very good chance that it will have a remainder. In this case it didn't, but there is a good chance since we have to divide in order to find an average. When you have division, you rather assume that float will be necessary. But sum is an integer value. Now, as I've explained previously, if you want to use an integer value in an expression and there's only integer values, okay, size is a constant, sum is an integer, C will automatically truncate it to the answer to being integer, but we don't want that. We want to see the decimal places after the comma. So I had to typecast sum to floating point just to convince C then to give the answer in a floating point for us. Okay, so that's this statement here, brackets float before the sum. Will temporarily typecast sum just for this statement here, just for this arithmetic calculation. It will temporarily convert sum from integer to float and then calculate and find an answer that's also floating point value, and then of course insert that into our string.